Hi, in this video we're going to have a quick review of how we can do the calculations for the circuit. We need to calculate the value of this resistor, and then I'm going to show you how we can input those calculations into Word and format them nicely, hopefully nicely. Okay, so first of all, let's assume that you do know that that is a 24-volt supply. That's probably higher than any of my students will be using, but that doesn't matter. Calculations are still going to be the same, or the method of calculations. So you need to know the supply voltage there, okay, and I've got my assumptions here. The forward voltage, that's going to be the drop across the LED, and also the forward current, that's the same current going through the current limiting resistor and the LED. Now, where would I get those values from? Well, the supply voltage, that's going to be determined by the circuit and the maybe the power supply. The forward current, the forward voltage, they're going to come from the datasheet. Ideally, hopefully, you've got a datasheet, and so maybe you've got something like this, and it's going to give you maximum ratings. So it says your forward current must not exceed 15 milliamps. Okay, must not exceed. By the way, that's IF, the forward current, but that's the maximum. They don't give you a recommended, but fair safety margin, always halve the maximum, and that will be all right. Okay, or even less. Old LEDs might have actually needed 20 milliamps of forward current. Modern LEDs maximum, say 15, or maybe, yeah, something like that. But they can easily work quite nicely on much less. 5 milliamps, even 2 milliamps might be okay. I'm assuming for this example 8 milliamps, okay, but you can choose a value so long as it's less than the maximum, and ideally about half or less, because maximum means that it's going to have a slightly shortened life. Forward voltage is given as a typical value in this datasheet, typical 2.2 volts, maximum 2.8. Okay, so I'm assuming typical of 2.2. It gives you the forward current there of 20 milliamps. Well, look, maximum 15, so yeah, all right. It's not going to be these values exactly. Right. Okay, so let's go back to our Word document. So hopefully you understand where I've got the 2.2, that was the typical, and then 8 milliamps was roughly half the maximum, and supply is just what my supply is. Now, it might be, if you want to present this sort of stuff, you might want to say forward current, which is IF, and you shouldn't write it like that, okay? The F should be subscript small, and the way I do that, I just select the F and I press Control and then the equals. I'm sure you know what I'm talking about, but just in case, press equals there. Okay, so Control equals, and that will take you subscript. Hopefully, did you see that? Let's zoom in a bit. So that makes a subscript. In fact, if you do Control equals again, it goes back to normal. Okay, so Control equals, so IF. It should be capital F, by the way, just like the datasheet showed you. Forward voltage, so that was VF. So I'm going to write VF, capitals, oh sorry, VF, and I'm going to select that and Control equals VF. Okay, it just looks nice. Supply voltage, let's put it for completeness, that's VS, supply voltage, and like that. Okay, I think that's quite nice, like that. By the way, if I were presenting this for myself, I'd probably actually tabulate. I'd make a table of this, okay? But you know, do whatever you think is right. You could also, I mean, you could use tab key, wouldn't hurt, would it? Probably makes it look a bit nicer. Okay. Okay, current limiting resistor calculation. So if we know, let's just zoom out a bit. If we know the, what do we know? We know the voltage that's dropped across here. We know the supply voltage. So the voltage dropped here across here will be the remainder. In other words, 24 minus the 2.2, which will give us what, 21.8 volts we need to drop across this resistor. So 21.8, we know that it's going to be passing 8 milliamps, so we should be able to calculate the resistance. Okay, so should we do that? So what I'm going to do, I'm going to click here, and you'd need a little bit of an intro. If you're one of my students, give it a little bit of intro, explain what you're doing. After that intro, then what you can do is insert equation. By the way, I'm using an old version of Word here. It's on my home computer, but the Equation Editor I think is the same in more modern versions. It always centers it for some reason. So that's left aligned because that's just where I want it, but you might not actually want it left aligned. You might not. Make sure that you're still in Equation Tools Design, and we want to calculate the resistance, don't we? So I'm going to say R equals, and to do that now, well, Ohm's law says that R equals, let's do this as a fraction, R equals V over I. Okay, that's the general, Ohm's law. R equals V over I, V equals IR, or however you want to express it. Okay, let's now break that down a little bit. And so what we're going to say is that the voltage across the resistor is going to be the supply voltage. Remember that was Vs. Okay, so to do that I'm going to use a script this time. I'm going to say V capital S, okay, and then I'm going to do minus, let's get outside of the subscript, minus, and then let's go subscript again. So then we're going to have the forward voltage drop, so VF. Okay, so that's going to calculate that will give us the voltage drop across the resistor. Then IF, wasn't it? So go subscript again, and so IF. Okay, hopefully that makes sense so far. And then we can do equals, and then we can actually add some values to this. So fraction, I mean, you can do different ways of doing fractions. You could do it like that if you wanted, whatever. Okay, I like it like that. So the supply voltage is 24 minus the forward voltage 2.2. So I'm going to write it like that. I suppose you could write 24V minus 2.2V. Yeah, maybe I'm being wrong, but that's where I would write it. Okay, IF. Now we've got lots of options here. So we could say 8 MA, 8 milliamps. We could do this. We could do say like 8 times, oh hang on, do a superscript. We could say 8 times 10 to the minus 3, because that's milliamps, so you can write it like that if you want. So then we would then have to write A. Okay, how else? You could, if you want to, do 0.008 amps if you want it, whichever way you feel more comfortable with. Okay, I think I'll just write 8 MA. Okay, equals. Right, what do we need to do now? Well, we need to do the calculation, don't we? So yeah, actually I just downloaded this. You probably see this in maths, don't you? I've never used it before, so hopefully I'm going to get this right, because this is actually the calculator I use, but I thought I couldn't see on the screen because of the reflection. So let's actually try this. So okay, so 24. I can do 24 minus 2.2, but I'll just show you, just in case the numbers are more difficult. And then go down, and then so I'm actually going to do 8 times 10 to the minus 3. So you don't have to do it like that. As I say, it's up to you. And I'll do equals 2725 ohms. Okay, so 2725. All right, I'm sure you can find the ohm symbol somewhere, but it's not worth it. Okay, 2725R. There's a problem with that. 2725R is not like a resistor you're going to find if you go to the cabinet that we've got resistors in the classroom. So you'd really need to be looking at standard resistor sizes. I've got this. I just searched for E24 series. Now we actually have in the classroom, we have an incomplete set of E24. We have every other one, I think. So it's not quite E12. So anyway, but yeah. So if you were choosing resistor values and you're in the classroom, make sure that we actually have them. What did we say we wanted? 2725. Well, we got 27, so we'd have 2.7K, but not 2.725K. So if you want to make sure your current is less than the 8 milliamps, if that was important to you, you'd go up to 3K. So 3K, you'd need some explanation on that. Okay, so you need to explain that, I've calculated 2725, I don't have that value, I will go to the next value up to ensure that the current does not exceed 8 milliamps, if that is your requirement. Okay, now generally speaking for LEDs, LED type circuits like this one, you're not going to have 24 volt supply. You're probably going to have like I don't know, 5 volts, and then so you're only going to be dropping like about 3 volts or something over the resistor. But that's why I intentionally chose a higher voltage, so it makes it a little bit more valid in the power calculation. So if you want to know how much this resistor has to dissipate in electrical power, you need to do the calculation. Now, the calculation I would normally do is, let's just do this, so insert equation, and let's just go left again, okay. So I've normally, for the power, I would just say, for this I would just say, capital P, power equals I squared R. You'll see where I'm going in just a moment, just bear with me. So I squared, and then you don't need to do multiply. I mean, you can if you want. Okay, power equals I squared R, but the I squared, the current, we wanted 8 milliamps, but actually we've got less than 8 milliamps. Okay, hopefully that makes some sense, because we've chosen 3K, which is more than the 2.725K. So we're going to have less, so we actually really need to recap. If we want to be precise on this, we really need to recalculate the current. So that's what I'm going to do first. Now, once again, if you were doing this as a student exercise, you'd actually be writing a brief, really brief, recalculation of the current or whatever. So insert equation, Control L, got it over on the left hand side. So I'm going to recalculate the current. So I equals, so using Ohm's law again, what is I equals? I equals V over R. Okay, and so the current is going to equal, let's go another, yep, need the fraction again. So the V, so how many volts are we going to be dropping? It's 24, wasn't it? 24 minus 2.2 across the LED, and then the resistance this time is not going to be, what do we say, 2725, it's actually going to be 3000 or 3K. So you might want to put some units to this, I'm rushing along now. So then, okay, so then let's just all clear. So fraction. So you do 24, if you want to do it long-winded, 2.2, then go down, and then 3000. There we go, 7.26, because it's times 10 to minus 3, it's milliamps, so 7.2, well, 7.27 really, if you're going to round it, so 7.27 milliamps. Milliamps. Okay, this keyboard's a little bit sticky. Right. Okay, so that's actually the actual current, not the initially desired current, but I mean it's very, very close, and resistors are tolerance, plus minus 5% or whatever. So yeah, it's really, you almost just don't need to really bother to recalculate the current. I'm only doing it just in case someone says that I've used the wrong current. And then so equals, well, now it's going to be 7.27 milliamps squared. So let's do that as a script again. So 7.27 milliamps. Oh, came out of that by accident. Squared. And then let's multiply that. So this time I am going to use the multiply symbol there, times what, 3000. Okay, that would be 3000 ohms. Or of course you could do like 3K if you want. You don't have to say kilo ohms, 3K is fine. Particularly, I mean, you've said R there anyway, so we know what we're talking about. And then, so let's do that. So, oh, I'll just trap the calculator, but of course we can do it on here, can't we? Well, we've already got that value actually, so shall we just square that? Let's square that answer and then multiply it by 3000, which gives us 0.158, so 0.158 watts. Okay, watts of electrical power. Well, if you're one of my students in a classroom, we've pretty much, for general use, only got quarter watt resistors, okay? And quarter watt, in other words, 0.25 watts is, well, it's plenty enough for this then, isn't it? Because this is only going to dissipate 0.158 watts. So you'd need to have a small mention somewhere to say that the quarter watt resistor is perfectly fine because it exceeds the calculated power that will be dissipated. All right. I don't know whether that's helpful. I hope that's helpful to people. At least you've seen me use the equation editor, and I don't know, you might even find that useful. Okay. Right. Do give it a thumbs up. If you think it's useful, subscribe as well would be much appreciated. Okay. Thanks very much. Goodbye.